Hello, hello. So, this is our last bit of new information of this unit. It's very similar to yesterday. Yesterday, when we were looking at word problems, we were dealing with primarily equations and equal signs. So, this time, the difference with today is we should be on the page that says one. Oops. Let me pause this for just a second. Sorry about that. Had to get the screen to lock so I could write on it without things moving. All right, we should be on the page that says one variable inequality word problems. All right, so this time, right off the get-go, I'm going ahead and telling you, we are dealing with inequalities. So every single one of these, we're going to deal with an inequality. And there's going to be two steps to both of them. All right, A, writing the inequality, and then B, solving it. Okay, we've got to do both of them. So, reading through this first problem says, Elisa won 40 lollipops playing basketball at a school fair. She gave 2 to every student in her math class, and she has at least 7 lollipops left. All right, so our variable, we need to define our variable. It's going to be S, your number of students, because that's what we don't know. All right, and so if we write this equation, not equation, our inequality, she gave 2 to every student. So every student received 2. So we could do 2 times S. I do a cursive S in math, so that's what that is. That's an S. 2 times S. Then it says she has at least 40 lollipops left. So we know we're going to have 40 on the right-hand side. All right, she has at least 7 lollipops left. So to think of this, if you were to go back to our that graphic organizer that we had at the very beginning, this is where some of those keywords and phrases may be most helpful for you. So go ahead and pause this, find that graphic organizer and get that out. I actually pulled mine up to my key right here. And so in our problem, it says at least 7 lollipops left. All right, so she has 7 more than what she gave away. So that's from what she gave away is 2 times S. So she at least has 7 more. So we're going to add 7 because she has at least 7 more than what she gave away. Now, if we look back at our little graphic organizer here, if we find where our keyword of at least falls into the greater than or equal to category. So finding it, I don't know if I can write down here. So finding it down at that bottom, the 3rd row area. So 7 being at least, having at least 7 left, that is going to be greater than or equal to our 40, which is how many she had total. All right, so now we just need to solve our inequality, which is what step B is. So it says solve it to find the maximum number of students in her class. It's also where a key point of where my variable came from. So we have 2s plus 7 is greater than or equal to 40. Subtract 7 from both sides. 2s is greater than or equal to 33. Divide by 2. And so s in this category is greater than or equal to 16.5. All right, that's not where we need to stop because we need to put it in terms of this word problem. So this word problem says the maximum number of students. So x has to be greater than or equal to 16.5, right? You can't have 0.5 of a student. You can't have half of a student. So our maximum number, so the maximum number of students is just going to be 16. So the maximum number of students is 16. All right, let's try another one. I know these are a little bit different because it's really focusing in on the wording. So it says here, more than 450 students went on a field trip. 10 buses were filled, and 5 more students traveled in a car. Write an inequality to represent this situation. All right, and it says when we're solving our inequality, we're finding the minimum number of people on each bus. All right, so that's kind of a nice, helpful hint of what we're trying to find. So I'm going to do a P for people. You could really do whatever variable you want to, but in this case, I'm going to do P. All right. So if we figured this out, so it says more than 450 people went on the field trip. So 450 people. So more than 450 people went on the field trip. I'm kind of doing this one backwards because on the left-hand side over here that I'm going to fill in are my people who went on the field trip. So that left-hand side is going to be greater than 450 because more than 450 people went on the trip. So then it says 10 buses were filled and 5 more traveled in a car. So that's what's going to go on this left-hand side. 10 buses were filled with, we don't know how many people, so 10 times P. And then an additional 5 were in a car. So we would add an additional 5 students. That would be our inequality. So if we take this, now we're going to solve our inequality. 10P plus 5 is greater than 450. Subtract 5 from both sides. 10P is greater than 445. Divide both sides by 10. And so we have P is greater than 44.5. All right, so this time it's asking us to find the minimum number of people. All right, so the absolute minimum, the smallest we can go. All right, our people has to be larger. The number of people has to be larger than 44.5. Well, we can't have half of a person, so we can't just stick with 44.5. And it has to, our minimum has to be greater than 44.5. So we need to have a whole number. So our next whole number that is greater than 44.5 is going to be 45. So for this problem, we're going to round up. So we would have 45 students, or 45 people, I guess I should say, since we're solving for, I had specified people, 45 people per bus. So if we kind of compare these two and why we rounded up or rounded down, all right, it goes with the finding, 2 was finding the minimum number, and B was finding that maximum number. All right, so that's kind of where the difference lies with that. All right, let's do another one. Let's do number 3. It says Bill spent less than, there's a keyword there, less than $26 on a magazine and 5 composition books. So we got a magazine and a composition book. The magazine cost $4. We know how much the magazine cost. It says write an inequality to represent this equation. So if we kind of look ahead, we're solving to find the maximum cost for each composition book. So my variable could be a C for the cost of composition book, since that's what I'm going to eventually be trying to solve for. So he spent less than $26. So we know that $26 is more than whatever he spent. And whatever he spent is going to be on this left-hand side. Well, he spent $4 on a magazine and he bought 5 composition books. So we can do 5 times C, whatever the cost of the composition books are. and then we would add the $4 he spent on the magazine. All right, so now we can solve that. So 5C plus 4 is less than 26. Subtract 4 from both sides. 5C is less than 22. Divide both sides by 5. C is going to be less than, so if you do 22 divided by 5 is 4.4. Now we're talking money here, all right? And since we are talking money, we can keep that. So the cost is going to be less than $4.40. All right, so that would be the absolute maximum. All right, it's going to be less than that. Really, if you want to be super technical, the absolute maximum, absolute max would be $4.39 because we aren't going to be equal to 40 cents, right? We don't have less than or equal to, we have less than. So that absolute max would be $4.39. Let's do one more together. It says Amanda rented a bike from Shauna's Bikes. They charge her $2 per hour plus a $10 fee. Amanda paid less than $27. So write our inequality. If we kind of skip down to B, get a hint, we're finding the maximum number of hours. So that could be our variable. H would be our number of hours. So if we write this inequality, we know she paid less than $27. And the key is to figure out, okay, what's going to go on that right on that left-hand side since we are less than $27. So we go look back at how they charge you. They charge $2 per hour plus a standard $10 fee. So $2 per hour plus that $10 fee. And then we solve it. 2H plus 10 less than 27. Subtract 10 from both sides. 2H is less than 17. Divide by 2, not H. So sorry. So it says H, our hours, has to be less than 8.5 hours. So with this, when it says maximum number of hours, it'll be fine. It's okay. So for both of these, 3 and 4, when it's talking about the maximum cost, maximum number of hours, it's okay to just leave it just like that, where it has to be less than 8.5 hours, less than $4.40. Because in finding that absolute max is a little bit weirder, but you're more than welcome to write that. So this absolute max, because we can't be equal to 8.5 hours, would be 8 hours and 29 minutes. All right, I want you to try number 5 on your own. So go ahead and pause this real quick and see how you handle number 5 on your own. See if you can set that up. All right, hopefully you did pause this and try it. Let's see how you did. All right, so number 5 says you need to buy some pencils and an eraser. You spend no more than $5. So no more than $5. But we can spend $5. It just says no more than $5. Eraser costs $1 and the pencils cost 0.25 each. Write inequality to represent our situation. And be sure to define our variable. All right, so we've got to be a little bit more careful with this language. It says buy some pencils. So pencils is plural. So we're buying multiple pencils, but then it says an eraser. So that is a single eraser. All right, that'll kind of help with setting up this inequality. All right, so if we're defining our variable, solve the inequality to find the maximum number of pencils. So it doesn't really matter what variable you went with. You could have said x and it equals anything. All right, I'm going to say p equals our pencils, just because I like for that to match. If you didn't choose that, that's okay. So it says we spent no more than $5. So our answer is going to be, so 5 is greater than or equal to. So it says we spent no more than $5. Again, we could go back to this little, our graphic organizer here. No more than is our greater than or equal to sign. So that's why I'm getting, that's why I know that it's that equal sign, because I referenced back to this sheet. So no more than $5. And so if we set up what we spent on the left-hand side, it says we spent 0.25 cents per pencil. That's what we don't know. So 0.25 times P, because we don't know how many pencils we spent or we bought. And then plus that $1 for our eraser. All right, so now that we have that set up, we can solve. So 0.25p plus 1 is greater than, or is less than or equal to 5. Subtract 1 from both sides. So 0.25p is less than or equal to 4. Divide by 0.25 on both sides. So you're left with p is less than or equal to 16. All right, so our maximum number of pencils would be 16 pencils. All right, this is where we're going to stop in the video notes. We'll look at 6, 7, and 8 tomorrow during class, and then we'll have another activity to look at during class. So please come in with any questions that you may have.